And then we are going to share our screen. So today we will move to the last part of this class, okay? We will start about a case study about the data analysis and use what we already learned of the concepts. So in this regarding, for this case study, I also have a link. If you want, you can also go to the link to get detailed information. So it's about movie rating. It's about movie rating. Still have a waiting room. Hold on, okay. Let me. There's still some people in the. Okay, let me admit all. So it's about movie rating data and how do we analysis. Okay, so that's the why someone kind of the sharing screen. I think I need to later on let me figure out okay how to, because it looks like someone is drawing something here. And about the movie, and I also have that. I also have the data set. Just keep having people coming in. So I have the data set also available on our website, so you can download it. So the very first thing we do is this data set is quite large and comprehensive. Okay, so let's see. And then you will see you can do a lot with the data, because in the real business world, especially nowadays, there are all sorts of things you can do analysis, okay? And then you can do some modeling, etc. Like for the current, like for the COVID-19, there are a lot of things you can do it, is it? And so for this case, it's about the movie and the movie data, and it's from some movie database, okay, TMDB, the database. It's one of the popular, okay, about the movies regarding rating, popularity, all sorts of information, okay, and then try to find some trend, etc. So this part we all quite familiar, so just read the CSV, etc. And then if you want, you can get some glimpse of your information. So this is regarding the head, etc. So if you take a close look, you will see the feature, etc. It has 21 columns. So here we call it features. So features, last class, we also discussed, it's quite useful for modeling. Is there for modeling, okay? And the modeling, last class, we also discussed there are two ways to do modeling: machine learning, modeling, is it? And that's one of the biggest part in recent number of years, okay, because of the availability of Python's package, okay, the sklearn package, and especially right now with TensorFlow, okay, the deep learnings and all sorts of deep learning packages, so quite useful. And so that's regarding feature, very useful for modeling. And in this case, we have 21 columns, okay, and it has a mixed format. It has number, is it, like popularity, budget, they are numbers, is it? But they also have some other type, like a string, etc. So how are we going to analyze of this? So let's take a look. So that's just some general information. And if you wanted to know the detailed information, because a lot of time your data you get from internet, okay, it's kind of messy, so you need to know in detail then to do the analysis. And also a lot of times the data you get from internet, it's not going to be directly from as the CSV file. Exactly. A lot of time the data you get from internet is JSON file format. That, and then you need to do some conversion. Okay, so a lot of data processing work you need to do, pre-processing work. And then in this case, generally speaking, we did this. Is it you kind of wanted to know the more detailed information about of the columns? Is this over here? It shows number of records regarding that column. And if you take a close look, you will find not they are not all the same size here. Is it? So like ID, they have 10,888, is it? But if you take a look for the homepage column, it only has 2,900 something, is it, record? So it's not all the same size, is it? So that's just give us some glimpse of the whole data, is it? The whole data. So, and then generally speaking, when we discuss the data, we also want to take some other general summary information about our data. As you can use the describe function. The describe function then over here to generally tell you, you see, the number of record for certain column, is it? And also minimum and the standard deviation, a mean, and the 25, 50, 75 percentage quantile, is it? And later on, we are also going to see those information. Later on, we are also going to use it, okay? So this is the general information. Generally speaking, whenever you get some data, you need to do those kind of general retrieving so that you understand your data, okay? And then you can do the further analysis. So that's a general. And then after you do analyze, okay, the columns, is it? And then you may want to, like regarding movie over here, what the author says is it want to find out, because the original data, when you look at it, you will find for the budget and the revenue column, is there are some zero data, but it shouldn't. That's the intuition. It shouldn't, but why it has some? Is it? So, and also you want to find out, are there a lot of those kind of data? Because if there are a lot, if you want to do some further modeling work in the future, then that's not going to work. Is it? So you want to find out. So over here, then what you can do is, here it shows, is it? So first you can find out, okay, all of the budget are zero. Is it? Then in this case, we can use this condition, is it? Previously we learned with Python, is it? And with data frame, then you can just use this condition to check if it is zero. And if it is, we do filtering work, is it? Previously, we learned this. This is called filtering, is it? And you can use a certain condition, not just equal. You can also make some other condition, greater than or less than, those kind of conditions, is it? And find out, okay, the budget to zero, is it? And over here, what the author did is, okay, then try to get some detailed information about the first three ones, is it? What are those regarding budget to zero? So the author found out about the first three, is it? Because once you find out the first three, then the author said what it next did is, because you want to know why in this data collection, the revenue is zero, is it? Oh, the budget is zero, is it? You may be curious, is it? So then the author did some deep investigation, as I said, to Google it, is it? And it said that not because the movie is really budget zero, there is no such thing happens, and it has some budget information. That's just in this data set, it's not got collected. is it? So in the real world scenario, maybe if you can find the data, and then you can, if you really need to do the modeling, then you can use some other channel source to get the data and then fill the data. So that's, and over here, the author just say, okay, fine, it does have the budget, is it? So that later on it can make some decision, is it? And then what next try to see, because you want to see if there are a lot or just a few as budget zero, is it? Because if it's few, then maybe it won't have great impact, is it? Then you want to know if you want to drop them out, is it? But the normal, generally speaking, when we do data analysis and modeling, if there are a few, you can drop. But if there are a lot, then you cannot, is it? So then you need to decide if you want to drop. Normally, it depends on the numbers, is it? So then in this case, you need to do some kind of counting, is it? So some kind of counting, then over here, what it does is it first do group by the budget, okay? And the group by, and then you can count, okay? You can count. And if you just do group by, and over here, we also specify the ideas, because if you just did group by, and what you will get is not a single column, you will get a lot of column of the 21 columns, is it? But over here, I just interested in the ID part, is it? So just to show that. So that's where this comes from. Then in this case, what it did show, you can find for budget zero, is it budget zero? There are quite a number of, it's over 5,000, okay, in this data collection. There are over 5,000 has zero budget information. Okay, so then that means you cannot just drop off that, okay, in this scenario. And then let's move on, okay. So over that, it's regarding budget information, is it? And then next, they also said, okay, because the author also said some revenue also has some zero, is it? So then how about I also do something regarding revenue? Okay, I wanted to know how many revenue zero items, is it? So what it did is it also do the group by, is it just as the budget, same case. And then you do count, is it? Do count. And then I just want to get to the single column, not everything, is it? And then over here, you can find out there are also quite a number, over 6,000 of zero for revenue cases, is it? So we need to find some way, is it? So revenue, and over next, what the author did is also try to find the runtime, okay? How many are the zero? And the runtime, then you can find it's just 30 something. So compare the overall you have over 10,000 records, is it? So that's far less than the overall. So then it says you can just decide to drop that, okay? So this purely depends on the scale, okay? Okay, and then, so once you get some picture about the zero value or data in your whole data set, then you can start to do some cleaning work, okay? And for the cleaning work, like over here says, do we need to drop unnecessary column, is it? So you also need to identify which column are necessary, is it, for your analysis. So in this case, the author identifies some of the column, like a homepage column, tag line, okay, the IMDb ID, is it, overview, budget adjustment, revenue adjustment. Those columns, the author don't think it's important for this research, is it? So author decide to drop that. So that's one thing. The second is some duplicate record, is it? And of course, you can drop that, is it? And then the third thing to do the cleaning, to drop some null value, because some columns, they may have null values, is it? Null value, but just like the 0 value one, is it? Are there a lot or not a lot? Over here it says, drop the null value with a small quantity of null, okay, not the large one. And then over here it says, can drop some of, but just the column with a small quantity, okay? And then for the 0 value, and we also just say, therefore budget and revenue, you cannot completely drop 2 columns, is it? Because there are a large number of that. So then you decide you need to replace that, is it? And how do we replace, is it? So that's another question. And the 0 volume columns, is it? And which one you want to drop. Then it says, okay, because the runtime, we just see there are not a lot of records. So you can go ahead to drop it. So that's the general analysis regarding the unnecessary column, duplicate value, null value, 0 value, etc. of those, how we do further. And then what's next is said is start to do the data cleaning, is it? So the very first step is to drop all unnecessary columns, okay? All unnecessary, and previously we learned you can do the drop, is it? For data frame, pandas data frame, you can just do the drop. And over here you can list all of the column name, is it? The column name you want to drop in a list. And then you just apply it to your data frame and call the drop method, the drop function. But also be careful, you want it to do impact on your original one. So you just specify in place as true, okay? So those little details in, just be careful. And after that, you can just do some check, okay, to see if the columns are dropped, okay. So that's the first case. And then the second case is we are going to drop a duplicate. Okay, so drop duplicate, you just call the drop duplicate function. Is it the same thing? You set in place option as true, okay. And then what next it's going to do is it's going to drop some null values, but small ones, is it? And so same thing, you list off the column in a list, is it? And then this time it's drop null values, okay? So you just add as drop NA, not drop, drop NA, okay? And then you specify the columns you want to drop, is it? And also you needed to specify you want to drop as a how, it's any or all, is it? And also the option in place, okay? So after this, the null value also dropped. And after that, you can also do some check, is it? So here it does a check to see if your data still have some null values, is it? And over here, you can still find like a keyword, is it? It still have certain number of null values, and the production component also have some null values there, okay? So that's what this part did. And then the next part comes to the 0 values, is it? How are we going to do those huge number of 0 values? And in this case, the author decided to replace 0 value with null value, okay? And generally speaking, when you do modeling, normally you cannot do this, okay, with null value. Normally you replace that with some interpolated data, or like in this case, a lot of movies budget, maybe you can find it from some other source, is it other channel, then you can go ahead to find from other channel and replace them, is it? So there are multiple ways you can do. But anyway, over here, what it does, it is replace with null values, okay, for budget and the revenue. That's what it did over here in this case. And after that, it just try to get a glimpse of your data. So it calls the information again to see, okay? And you can see all of the remained columns, is it? And the number of the items, total number of items, and the null values, is it? So you get all of the information here. And then what the next part is going to do is the runtime, is it runtime 0, okay? And just double check over here, because we already drop off the runtime at 0, then you can do the query to check if the runtime 0 already dropped, and you can find it's already dropped, okay? So that's of the data cleaning part. And after you finish off the data cleaning part, you can, over here it says cleaning result summary. Okay. So you can get another check about your cleaning work, is it? And over here you get some basic information, total number of columns, is it? And for each column, you will find how many rows for each column you have, is it? With the null values, and what's the data type, is it? So you can have all of those information. Okay, and then you, if you want a lot of time, you also want to get a glimpse of the overall data, is it? So you can call describe function to get some general idea about, because over here, it not just list the column, is it? It also gave you the distribution information, the mean value, standard value, is it mean, minimum, maximum, and the different quantile, percentage quantile distribution, is it? So that you can, because sometimes you want to find out if there are a lot of outliers, something like that, is that those kind of information, okay? Okay, and then, so all we discussed before regarding data cleaning part. So generally speaking, that's the first part. When you start to do the data analysis, you need to do the data cleaning. And what's the next part? We call it data exploratory, is it? So EDA. So in data now you may also see this word a lot, the abbreviation EDA. Okay, EDA so means exploratory data analysis. Okay, data. And in this case study, the author divides the research, the analysis into 3 parts of research. Okay, so you kind of needed to do the dividing work, etc. And then smaller, make your whole project into smaller parts. So the first part the author does is general explore. Okay, so general explore, then there are some questions that you may ask. You want to give your research some direction, that. And in this case, maybe you're interested in about popularity over the years, that. Maybe like for business, like for grocery store, you want to know, okay, which food item sell the best, that. Something like those. And the second question is that you want to know the distribution of popularity, is it, versus the revenue, different revenue levels, is it? Not all of the years, probably just the most recent 5 years. And the third question, the author interested is the distribution of score, the rating score, also in different revenue level, etc., and also in recent 5 years. And you can also do historical data, this kind of analysis, okay? So that's the first part. It's just a general explore. Okay, so you and if you work for some clients, generally speaking, clients will have the questions for you. That they want to you to find out some pattern. That then you can do the investigation. And the second part of research is as find the property associated with successful movies. Is that because then in the future, when you produce a movie, you can follow this kind of property. So that's why you're interested. And in this case, the question says, what kind of property associated with movie that has high popularity? It's a popular movie. Why it makes the movie popular? Is it? And also the rating score, why it is high? Is it what kind of property? And you want to find out about those. And the third part of the research is just the keywords and the genre, that by the generation, that is the number of movies released year by year. Okay, the keyword trend by generation, that and the genres by the generation. Okay, so you have this three part of research, and then try to do part by part. So the first part is general exploration. General is first is popularity over the years. Okay, and then you need to take another look of the data. Is it? So here is just, okay, get some information of the data. And then what the author says is that to analyze the question, the author first computed the mean of the popularity. Okay, the mean. And then does some plotting, okay, later on. So visualization, okay, for data analysis and machine learning, visualization is also a very important part, okay. And not just does the mean, it also do the media, okay, to help, because it says in case of the mean popularity affected by the outliers. That, okay, then let's see how the author did, okay. So what it did is regarding the popularity, that regarding the popularity, and it's grouped by what? The release year, okay, and find the mean value, okay, find the mean value. And then over here, it's just show the last part. And here, why it's the tail part is because previously, when you said it's you wanted to find the popularity in recent 5 years, that, so that's why over here you're interested in getting the tail part, okay? So the latest 5 years, that the popularity mean, that and grouped by the release year, okay? And then it also find the media value, okay, the popularity. Because in this case, they also try to explain that to prevent the outliers heavy impact, okay, to get some idea. And then what's the next part did is to do some visualization over here, okay, visualization. And then let's see, how did it do that? So the first, the author said you needed to build the index location for the x-axis, okay? So you get, so over here we have the P mean, the popularity mean, and the popularity media, that, and you have the release year, and you also have the popularity, that. So we are going to do the drawing, so you needed to have the index, that, for the x-axis, okay? So that's that part. And over here for the drawing, it uses CBOM. Okay, previously we learned that there are multiple ways you can do plotting. And one nice thing for CBOM is CBOM can generate quite a pretty plotting. So, and for this CBOM, what the style is said, it uses grid style. Okay, so we will see the result. And then you set the X and the Y value for your drawing. Okay, so this is just a very general drawing. Okay, and then you specify the figure, is it? Then you can do the plot. Okay, do the, and you also specify the color, is it? And the label. Okay, for your drawing part, okay. And then it also specifies a legendary, okay. So the plotting result, it shows here. That, so once you have this plotting, then you can kind of see that the mean and the median, the trending, that, and the trending, it over here, it kind of shows very abrupt rise, that for the popularity in recent number of years. So it popularity raised a lot. That, so that's why we a lot of times say, okay, the plotting helps you a lot for you to get the trend of your data. That is over here we did see, okay. And for the media, I didn't see that huge bump. That, so that's the first question. We kind of get some idea about the popularity trending in recent number of years. Is that we kind of have that idea. And then the question, second question to answer is try to answer the distribution of the popularity. Is it in different revenue levels in recent years? Is it? So here it says you need to divide your revenue into different levels. So what the author did is it did divide the revenue into 4 levels. So cheaper budget or revenue, is it, and medium or moderately high or high, is it, into these 4 quantiles, okay. And then to do that, so how do you collect the data for the 4 quantiles, is it? So what over here the author did, the author wrote a function called cut into, cut into the, why it's, so it won't work. So the author create a function called cut into quantile. For this, it pass in the data frame and also which column you're going to cut into different quantile, okay? So here they also use a very wise way, is it? Because you remember in describe function, that describe, it gives you the minimum, is it, and the maximum, is it, and the different quantile percentage, is it. So over here, the author just directly borrow that describe part, is it, and just specify the column name, is it, and get the minimum 25% quantile, then from which row, is it? So index 4, index 5, and index 6, then you get a different one from that describe result. And after that, then you can do, because we are going to call that cut function. Cut function in our previous unit we learned, is it? And because you wanted to do some bin counts, kind of, is it? So the bin edges, then in this case, then you can use whatever the data defined over there, is it, to define those as your each of your bin. So you're going to have multiple intervals here, is it? And then you have the edge starting and end, starting and end, is it? So over here. So that's where we define the bin edges here for our interval edges, is it? And then you also give your each of the bin a name, okay? So that's what this 2 statement did. And then you can call the cut function, okay? And the cut function, you specify by which column you're going to do the cut, okay, the bin cut. And then you specify your interval levels and the name, okay? And it's included lowest or not, okay? And after this, then you will have the different level of the data count into different bins, okay? So that's regarding that part. And then next part is that because you want to find the distribution, is it in just different revenue level, we already taken care of. Revenue level, we already taken care of. And we just want to know in recent 5 years, is it? So that's why over here, the author is also going to get the recent 5 years of data, is it? So then over here, what the author did is loop through the year, is it? Loop through year. And then you get the year's data, the specific year data. And then you are going to specify, I'm going to get them into different quantile, is it based on revenue over here, okay? Then you call that cut function, that cut into different quantile function, you call it, okay? And then you just keep adding each of the quantile, is it, to this new data frame, okay? So that's regarding this part. You get all of your data into the new data frame because later on we are going to use that. And then you're going to do the same thing for the media, okay, the revenue media. So exactly same thing as what we just did. Do the group by, and this time it's release year and then the revenue levels, is it? And over here, we see, is it the quantile we already, so this data, this DFQ2 data, it's already, we already call that cut into quantile function, is it? And group them into different quantile, is it? And then you can just do group by, is it? Release year and the revenue levels. And over here, you are going to find the media value in this report. So that's, and over here, the result also shows us it's a multi-level of index. And you can also do the rotating, is it? Over here, we call unstack to rotate the level to the column, okay? And after that, then we can do the plotting, is it? So you can plot. And over here, we do the bar plotting to visualize. So that's the result. So the result shows us the distribution of different level. Okay, so this regarding the revenue levels, is it? And the different level, the revenue, and we can also see its distribution trend, is it? And from the result, this visualization result is quite clear, is it? So this red one, the red one is a high revenue, is it? High revenue. High revenue, and you can also see the popularity is also the highest. Okay, so it looks like the more money you spend, the more popular the movie is going to be, is it? So the result shows it's popularity related with the money you spend. Okay, that's no, not this. This is not revenue. This is this is revenue, not the money you spend. This is the money you earn. Okay, and of course it's obvious, is it? The more popular, the more money you can earn because more people watch the movie. And what the next part shows is, if we take a look, it's similar as what the previous drawing, is it? It's based on release year, and the popularity also based on the revenue level. But this time it's just, so it's based on your customer demands, is it? What kind of visualizations you want to generate, is it? Because compare this one, compare with the other one, it looks more pretty, is it? And So if you want to generate some more pretty drawing here, it also shows us one way to do it. So over here, you manually do the plotting of the bars, is it? So if you take a look, you see, you do each of the bar drawing. Okay, manually you call that a bar. So for each of the bar over here, so we have the full bar drawing. Okay, so it's more detailed specification of your bar drawing. Okay, so if you want, you can also try with this kind of visualization result. So that's regarding popularity. Is that the relationship between popularity and the revenue? And from the result, you can find out that high revenue also aligned with the higher popularity. Okay. And what the next part shows is about the scoring. Okay, the voting scoring. So the rating and the relationship also between the revenue and the voting. And it's a pretty similar result. That pretty similar procedure if you want to do the visualization generation result, because we already have that DFQ2. That, and here you just want to get out of the voting ones. That, and for the result, if you take a look, you will find out it's not that highly correlated between your voting score and the revenue. Is it? So it's not that highly correlated as popularity. So the next part is similar. It's just another kind of visualization result showing. So it's more detailed and fine-tuned. So that's the first part of the research, okay? So first part of research, after you do this analysis, then you can get some summary result. The summary result from the analysis, you can find out it says the popularity trend, is it? It's growing or decreasing, is it? And the revenue level and the popularity in recent 5 years, is it? And the revenue level and the voting scoring, is it? So from the first part analysis, so we get the kind of glimpse of how we do the analysis. So generally speaking, over here, you also get some basic idea about how you're going to do your final project. So for your final project, you need to do some similar work. So you pick some data set. It's going to be the real world, because we are going to go to some competition website, okay? So you pick some real world data set, and then you need to do the data cleaning work. But the majority of the work is just like what this case study shows, is you need to, because that's the competition question. So generally speaking, they also have some questions they want you to do, is it? So you can follow their question, and you can also find some pattern that you want to present for from the data set. So that's the general idea. And we just, because the case study is quite comprehensive, so today we only get a chance to finish the first part. The other two parts we will finish next week. And there are a couple of more case studies. So I will just go over those case studies so that you have some idea how you are going to do your final project. Okay, based on of the knowledge that you learned this whole semester. So that's the general idea. And so today we're just going to stop here. Do you have any other questions? And before we finish, just one more time, I'm going to promote my next semester class. So next semester, I have the machine learning class. So I'm going to repeat. And for under, it's CS453, and for graduate CS634. Okay, and it's machine learning. And so it's more systematic study about machine learning, all sorts of machine learning models. And because this semester you already know how to do the analysis part, the data analysis part. So next semester it's a different route, but you already have the knowledge. And so the machine learning part focus more about how do you train the data, and then you can do the prediction. Okay, so it's going to be adds-on value for CS433 and the CS630. Okay, and if you check a lot of job website, normally a lot of data analysis, analytic work, they also need you to know some machine learning background. Okay. Okay, so that's all the information for today, and I will see you next week. Oh, before for CS433, and you can send me to the chat about your name just. So just CS for just graduate, because graduate we need to collect the attendance information. Okay, that's all. So if you are undergraduate for 30, so you just send me your name. Okay. Then I'm going to see you all next week.